There seems to be some difficulty with the idea that empirical inference assumes an absolute. Empiricism is observation. That's it. An empirical study of the tensile strength of a rod of steel is specific to that rod, and conclusions are meaningful only in reference to that rod. The greatest pressure the rod could withstand before buckling is measured and recorded and considered its tensile strength. At this point, no absolute is assumed. The moment we use observation as a mode of inference, in other words, to predict the tensile strength of similar rods, inferring our prediction from the observation of our particular rod, an absolute is then assumed. To assume that what is observed with x will happen to x prime at any other time, under similar conditions, is to assume an absolute of x. It was proposed to me that empirical inference would still be justified in a situation where gravity only worked 30% of the time, intending to suggest, I here assume, a situation in which the variable was not, as he claimed, absolute. The problem is that to say gravity only works 30% of the time is itself to assume an absolute characteristic of gravity. To predict that, say, tomorrow gravity will only work 30% of the time based on past observation is still indicative of an absolute principle at the heart of the phenomenon of gravity. The only way we get around that, the only way we get away from assuming an absolute, is if in fact tomorrow the percent of time gravity doesn't work was purely random. In such a universe, empirical inference would only predict as good as chance. You probably know the tired question of whether or not a tree would make a sound when it falls over in a forest with no one around to hear it. The empiricist would think it would, and should probably wonder if it was true that a tree would not make a sound, simply because no one was around to hear it, how the devil we were supposed to believe the tree could fall over in the first place without anyone to perceive that too. But never mind. We observe trees falling over, and we hear a sound. To infer from this observation that all trees make sounds when they fall over in forests is to assume an absolute of the phenomenon. If it was true that trees fall over in forests, but only made sounds based on some random variable, empiricism would be a flawed means of inference. It would be a flawed means of inferring or informing ourselves of other trees and their behavior when falling over. At this point in the conversation, I have had people claim either one of two things. Either that relativity theory challenges the idea of empirical inference, and that the idea that empirical inference assumes an absolute, or that quantum physics challenges the idea that empirical inference assumes an absolute. Relativity theory, however, does not suggest the world operates by randomness, but if you believe that it does, I would be interested in hearing your argument and hearing your demonstration of such. As for quantum physics, that deserves a video all to its own, so suffice it to say that apparent randomness is not proof of non-determinism. In empiricism, apparent randomness is interpreted as mere ignorance of the actual cause of the behavior of the variable. On top of that, a guy named Wolfram used mathematical algorithms to produce a number of chaotic and seemingly random patterns. And since these patterns were determined by an algorithm, the pattern itself was not truly random, even though it appeared to be such. This suggests that apparent randomness, like any that might be observed at the quantum level, is not necessarily evidence of a non-deterministic universe like so many people claim. Empiricism is observation, and that is it. We inform ourselves about a particular thing from our observation of that particular thing. To use empiricism as a means of inference, to inform us about other particular things that we have not directly observed, assumes that there is an absolute basis between the particular thing we have observed and the other particular things that we have not observed. If there is no absolute basis between these things, the particular thing we observe will not be informative of anything other than itself. And any attempt to predict the behavior of other particular things in reference to what we have observed would be futile and no better than chance.